One day, vast grasslands started to open. Clouds of volcanic gas and ash rose into the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. Not so long ago, there have been some curious changes in water levels in different parts of Yellowstone Lake. The water level could be rising on one side of the lake and falling on the other at the same time. It looked as if the lake basin was getting lifted by some underground forces. Is it a sign of a looming disaster? Is the Yellowstone supervolcano ready to erupt? Let's figure it out. Geysers, mud pots, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Such volcanoes produce super eruptions. When it happens, about 240 cubic miles of ash, molten rock, and hot gases get launched up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through the Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe that they had been created by many weak eruptions. But after doing some more research, experts found out that these deposits could have been left by a previously unknown super eruption that took place about 8.7 million years ago. A year before that event, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Experts think it was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on our planet, wasn't named supervolcano for nothing. There have been at least 3 other super eruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. By the way, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out so much boiling lava, it would be enough to fill Sydney Harbor 4,500 times. Scientists believe that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down. But back to the main question. Are we about to face another super eruption in the nearest future? It would be a catastrophic event. A massive column of lava and ash would rise into the air up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. Such a mixture of lava, ash, and gas would be immensely hot. Moreover, it would also move around at a speed of 300 miles per hour. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. When the ash got into the stratosphere, the temperatures all over the world would drop. In the worst-case scenario, the eruption would be very rich in sulfur. And since this substance is an effective sunblocker, the temperatures would get so low that there would be no summer in the world for the next several years. The seasons would change. Agriculture would face serious problems. The disaster would create disruptions in food supplies. The Federal Emergency Management Agency has estimated that the potential damage would make about $3 trillion in the US alone. But the good news is that scientists think that the Yellowstone supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Which means that the probability of the eruption is 1 in 730,000. This probably is almost the same as the probability of a big asteroid crashing into Earth. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the unusual activity going on there. Still, there have been tons of discussions about what people could do to prevent the disastrous super-eruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat coming from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano will erupt. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6-mile deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very nice. About 10 cents per kilowatt hour. Sounds like a great plan. Are there any drawbacks? Unfortunately, yeah. Let's say you're drilling a well to deliver cold water to the volcano. And then you accidentally hit its magma chamber. In this case, instead of cooling the giant down, you make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that this drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Or imagine drilling through Earth's crust, getting deeper and deeper. And then, wham, bam! You hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful blasts. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. But the worst thing? The project would last for thousands of years, up to 16,000. The problem is that by using this method, you can't cool the volcano faster than at a rate of 3 feet a year. On top of that, scientists aren't 100% sure that when they finish this project, the volcano will stay cold for at least 100 years. Yellowstone isn't the only supervolcano on Earth. Check out the list. It includes the Long Valley Caldera in California, the Etana Ignimbrite in Chile, Toba in Indonesia, Taupo in New Zealand, and so on.
It happened around 8.7 million years ago. All of a sudden, vast grasslands started to open. Clouds of volcanic gas and ash covered the sky. Flows of lava streamed down the hills and across the plains. Within minutes, black volcanic glass started to rain from above, wiping out animals, crushing plants. It didn't take long before the land caved in, opening giant pits filled with red-hot magma. It was the greatest eruption of the Yellowstone supervolcano. This giant, which is actually one of the largest active volcanic systems on the planet, wasn't named Supervolcano for nothing. Spreading deep underground and extending for hundreds of miles, Supervolcanoes are complicated structures. Experts are still unsure what processes can trigger these fire-breathing monsters and lead to super eruptions. When it happens, more than 240 cubic miles of ash, molten rock, and hot gases get hurled up into the air. 4 super eruptions would be enough to fill the Grand Canyon to the brim. Volcanoes create mountains, but supervolcanoes wipe them off the face of the earth. They change climates and ecosystems. Thankfully, these disastrous events don't happen more often than every 50,000 years or so. Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground and burst through the Earth's surface. Usually, all this magma gets stuck, unable to break through the planet's crust. Large pools of pressurized bubbling magma gather at a depth of several miles. The pressure keeps growing since more and more magma is trying to get to the surface. And then, wham, bam, a super eruption goes off. All those millions of years ago, the first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust, leaving behind huge chambers. Those were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding after more and more magma arrived with time. The land over the volcanic system was inching upward, slowly, almost unnoticeably. A year before the super eruption, Yellowstone gave a warning. But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression released gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle with soda after you've shaken it. Something like that was happening near the volcano. The pressure was released through the fractures when gases were bursting out from under the surface. Right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe, but the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurtled up into the air to a height of over 16 miles. Within several minutes, a pyroclastic flow rushed across the area at a phenomenal hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With the temperature of more than 1,300 degrees Fahrenheit, it was burning everything in its path. The volcano kept pumping ash for days on end. The air in that area heated up to 570 degrees Fahrenheit. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds after being inhaled and getting in the lungs. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a 10-feet layer of ash covered the territory of about 50 miles around the center of the eruption. In the end, tiny particles of volcanic ash coated almost all the western part of North America. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. The monsoon seasons changed. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It covered more than 8,900 square miles of what's now southern Idaho and northern Nevada. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. There have been at least 3 other supereruptions in the history of the Yellowstone volcano. They happened 2.1 million, 1.3 million, and 64,000 years ago. They were 6,000, 700, and 2,500 times more powerful than the devastating eruption of Mount St. Helens in Washington state in 1980. The most recent supereruption was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spewing out 240 cubic miles of rock, dust, and volcanic ash. These days, Yellowstone National Park is a mind-boggling collection of 10,000 mud pots, hot springs, geysers, and vents emitting volcanic gases. Heat-loving microorganisms live in most of them. They paint the park in its brilliant colors. The most famous geyser is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than others, erupting about 17 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach the height of 180 feet. Scientists have spent many years trying to figure out what's hiding under Yellowstone Park. They've discovered that surface water goes several miles down into the crust. It gets heated and boils, supplying the geysers. Around 7 miles below the surface, there's a reservoir of half-melted rock. That's the magma chamber, and it's more than 30 miles wide. An enormous plume of hot rock, which looks somewhat like a mushroom, feeds this chamber. It rises from the depth of 400 miles, traveling through the planet's upper mantle, a thick layer of mostly solid rock. Sometimes, this plume overheats the magma chamber. The land in that place lifts, and tiny earthquakes help some liquid escape to the surface. The pressure inside the chamber drops, and the ground lowers again. Since 2004, some parts of the Yellowstone Caldera, which is a clever word for a volcanic crater, have been surging upward much faster than usual. The rate's been almost 3 inches per year. No uplift has been that quick since scientists started close observations in the 1970s. And still, experts are sure the supervolcano doesn't present any danger these days. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even if there's some volcanic activity, it's more likely to be a spurt of oozing molten rock, known as a lava flow. It does present some danger, but it's easily avoidable. Or it can be a hydrothermal explosion. Then, a large volume of superheated water trapped below the surface will rapidly turn from liquid into steam. This steam, along with boiling water, mud, and pieces of rock, will burst through the surface with great force. Then, the debris will litter the area of up to several miles in diameter.
Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner. But just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though, let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone Caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco Volcanic Field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco Volcanic Field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco Volcanic Field will remain a hidden gem of volcanic history, waiting for its next fiery performance.
In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Day 1. A small but powerful tremor is shaking the city of Naples, Italy. The news networks are reporting on the event. The experts believe that Mount Vesuvius, the stratovolcano on the Gulf of Naples, will explode soon. But when? It's erupted many times in the past. In fact, that's how it got its shape. It's made of multiple layers of hardened lava, pumice, and ash. Vesuvius last erupted in 1944. But a major blast happened there nearly 2,000 years ago. It buried the Roman towns of Pompeii and Herculaneum and decimated the surrounding areas. Today, 3 million people live less than 20 miles from the volcano, and 600,000 live in the danger zone. Large eruptions happen every few thousand years, usually after long periods of calm. And the trouble is, Vesuvius is long overdue for its next one. This time, though, the volcano is being watched by the Vesuvius Observatory. It has seismic stations, special GPS arrays, and satellite-based radar to help it measure ground movement. They also have special equipment to test the chemicals found in the gases coming from the volcano. All of this helps the experts work out whether it's about to go off. But will it? Right now, the magma is more than 6 miles from the surface. Things seemed safe yesterday, but now they're about to take a turn for the worse. Day 3. Another tremor comes in measuring 3 on the Richter scale. All the equipment that's installed near the volcano is now going off. The magma is pushing upwards. It's not at the surface yet, but Vesuvius is definitely restless. 2 more tremors follow in the afternoon. They don't feel like regular earthquakes, and geologists can see the difference in their seismographs. Volcanic quakes register about 4 to 5 less on the Richter scale. Now, the experts are sure it's just a matter of days or weeks until the volcano erupts. Some volcanoes can be restless for months or even years before they go off. But that's not how it goes with Vesuvius. Day 4. The ground starts to crack open, as if a giant creature is trapped in the Earth's crust and is trying to desperately get out for some air. Steam escapes from the little cracks in the soil. Certain areas are hotter than others. If you went there, it would feel like you walked straight into an oven, and it would be hard to breathe. Some sheep got too close to the mountain and passed out. When the farmer found them, he almost collapsed too, not from the heat, but from the gases. Carbon dioxide and hydrogen sulfide are being released into the air. The entire area around the volcano smells like rotten eggs, and many of the forest animals are now staying clear. The nearby trees have been absorbing these gases from the soil for days on end now, and they're starting to turn brown. The carbon dioxide levels in the area are skyrocketing, and all the detectors are beeping constantly. Day 6. The tremors are getting more frequent. Experts at the Vesuvius Observatory monitoring the volcano say the quakes are coming from the magma that's being pushed upwards. A few hours later, the national emergency alert goes out. Thousands of local people have around 15 days before the volcano erupts, and they need to evacuate their homes. The 600,000 people in the danger zone start to pack their suitcases and leave in cars and trucks. There's chaos everywhere. But in all that disorder, some people are standing still. They look around, trying to understand what's really going on. A few of them are taking photos of their homes. Others are streaming all the confusion on social media. But the senior citizens are just standing outside, looking at their houses one last time. They hope this is all just a false alarm. It's happened before, but who really knows? Day 7. It was a sleepless night. Plenty of the locals have already left. Some good people from other towns drive to the area to help the residents evacuate faster. There's a massive traffic jam, but everyone expected it. This is why the evacuation started early. Ferries, trains, and buses have canceled their services to help the evacuees. They're all working on a tight schedule to make sure everyone gets out safe without any delays. Some people refuse to leave, but their neighbors eventually convince them to go. It will take 7 days to evacuate everyone, and these people will spread out to other areas of the country, not just to the nearby safe regions. Day 10. More than half of the residents have now left the red zone. After the chaos, there's now silence, and it's interrupted by the eerie sounds of the tremors. Animals are being evacuated too. Many people are now trying to save as many animals from the forest as they can find. Day 16. All 25 of the towns that were at risk have now been evacuated. The red zone is empty. But the tremors are getting stronger, as the volcano is a pressure cooker ready to explode. White smoke rises from the large opening on the mountaintop and the vents on the side. The molten rock moves toward the surface, and the pressurized gases form bubbles, just like the ones you see when you boil food. Suddenly, there are some loud booms, and then an explosion. It's loud enough to be heard thousands of miles away, and the shockwave is felt throughout Italy. Volcanic rock is thrown up into the air. A thick black mushroom cloud forms and expands into the sky. The birds abandon their nests and fly away in huge flocks. The red-hot lava is now spewing out of the volcano like a fountain. As it flows downward, it obliterates everything in its path. Then there's a volcanic landslide. Part of the cone-shaped mountain falls off, and millions of tons of soil and rock break loose from the volcano's side and tumble down. The lava spreads on the slopes, and it slowly slides down into the forest and the farmlands. The plume of ash, pumice, and other kinds of rock has risen so high into the sky that people can see it from Rome. Then the tower of debris starts falling back to Earth. First comes the ash, then chunks of rock. The ash in the atmosphere is so dense that it's hard to breathe. The lava slowly spreads across the area and pulls down all the trees. All the nearby towns are shrouded in darkness and smoke. Buildings collapse, and all around there's a mixture of heated, poisonous gas and rock moving faster than a car. Other rocks and more volcanic ash fall miles away from the volcano, hitting cars and destroying roofs. The sky is completely black as the lava keeps on coming. Slowly, all the nearby towns are submerged beneath the molten rock. Some of the lava even reaches the sea. Gigantic white steam covers the shore where it falls in, and the magma turns black. Now, a weird neon blue fire appears on the slopes of Vesuvius. This is caused by burning sulfuric gases. They're escaping at high pressure from the cracks in the volcano's surface. When they come into contact with the air, they ignite. These blue flames can reach 16 feet into the air. Now, all nearby flights are canceled, and many planes have to change course to reach their destination. Ever since the national alert, no planes have been allowed to fly over the volcano. The clouds of volcanic ash can damage jet engines and other plane components. The water supply is now contaminated by streams of volcanic ash, and it smells unbelievably bad. In just a short amount of time, all that magma has made entire towns vanish. Only the roofs of taller buildings can be seen. After the big and explosive eruption, there are some smaller and quieter ones. At this stage, nobody knows if the volcano has stopped erupting yet, and absolutely no one can go anywhere near the area. 10 years later. Most parts of the red zone are now hidden under hardened but still warm lava, including the ancient site of Pompeii. Some people have started to forget about what happened. Others have begun their new lives elsewhere, and some don't even want to think about what happened to their old homes. But several of them are counting the days until they can go back. 100 years later. You're walking in what appears to be a wasteland of volcanic ash. You suddenly realize that you're standing on top of your great-grandparents' town. Everything is now submerged under a thick carpet of solidified lava. But below it all, just about everything is still intact, completely frozen in time. Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt, and one day it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet, all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed, and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over, but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. Plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called Mushroom Pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. Imagine standing in the middle of Europe 40,000 years ago. The landscape is rough, cold, and unforgiving. Fast food is scarce, and there's no internet. Suddenly, from out of the woods steps a figure, stocky, strong, and with a face that is quite unusual. This human looks similar to us, but something about them is different. Their brow is heavy, their nose is broad, and their body seems to be built to fight nature itself. Well, congrats! You've just met a Neanderthal. You might have thought that Neanderthals were basically ancient humans, but that's not really true. We come from the same genus called Homo, but we, all modern humans, belong to one same species called Homo sapiens. However, there used to be lots of human species before, and Homo neanderthalensis was just one of them. And they actually were kind of cooler than us. So what in the world has happened to them? Neanderthals lived for a long time, for about 360,000 years, across Europe and parts of Asia. 40,000 years ago, the place we now call southern Italy was sitting on top of a huge disaster, a massive supervolcano called Campi Flegrei. This big boy is huge, about 9 miles wide. That's about 10 to 20 minutes in a car to get across it all. But there were no cars then, remember? At the time, it was quiet for a while, but one day, suddenly, it blew in what became one of the biggest volcanic eruptions Europe had seen in 200,000 years. The catastrophe was so crazy that ash, gases, and debris altered the climate across the entire continent. What comes next is usually called a volcanic winter. Average temperatures drop, the sky gets darker, and life becomes even harsher than it already is. The eruption, known as the Campanian Ingambrite, caused Europe to cool by as much as 7 degrees Fahrenheit. Doesn't sound like much? Well, the drop of even 1 degree would cause winters to become harsher, causing horrible snowfall, rains, and floods. Crops would struggle to grow, leading to food shortages. The weather would go wild, too, with storms and droughts. Hey, kind of like now. Except multiply this by 7. Events like these caused some huge chaos in modern times. You can imagine what it did to the Neanderthals. But in reality, a simple volcanic eruption shouldn't destroy an entire species, right? Well, yes. The truth is, the Neanderthals were already hanging by a thread back then, and all because of us. They've been in a tough spot for a while. They lived in places that are now parts of Europe, Western Asia, and the Middle East. Modern humans, us Homo sapiens, entered Europe and were giving them some serious competition for food and shelter. Homo sapiens were sneaky dudes, better at finding food, easily adapting to different environments, and using more advanced tools. We were pushing Neanderthals out, trying to get the same resources. We literally made their extinction a slow and very unpleasant process. So, while the volcano definitely made things worse, it wasn't their only problem, and they didn't completely disappear after the eruption. Some of them hung on in isolated places, like Gibraltar, for another 12,000 years. That's because it's likely most of the severe cooling actually happened farther east, away from where the Neanderthals were trying to survive, and it didn't hit their homes as hard as we thought. In fact, the eruption may have even helped them, at least for a while. Some scientists say that the volcanic fallout might have slowed down modern humans' expansion into Neanderthal territory and gave the poor fellas a little more time to survive. So, the Campi Flegrei eruption was a nasty event, but it only delayed the inevitable. Campi Flegrei is a wild card. It's also known as the Fields of Fire. The air itself there is thick with legend. The Greeks and Romans believed this volcano was the gateway to the underworld. Even an ancient Roman poet, Virgil, mentioned this in his famous story, the Aeneid. The hero Aeneas must descend into the underworld, and this place is exactly where he starts. Back in the day, this landscape was full of Roman villas, spas, and fish ponds. The elite had the time of their lives there. What they didn't know, though, was that they were standing on treacherous ground that could go crazy at any moment. The Campi Flegrei is not your typical volcano. You'd imagine a single towering peak, but the landscape looks deceivingly calm, with small features popping up here and there. But if you flew above it, the sight would be insane. A gigantic circular basin, peppered with volcanic cones and craters, like scars from the Earth's violent past. The danger here lies in its subtlety. The ground beneath your feet is constantly shifting, even when you don't notice it. Every so often, the land rises, only to sink again, sometimes by several feet, as magma or gas moves beneath the surface. It's incredibly creepy. The risk is almost invisible. The Campi Flegrei is a massive depression formed by 2 colossal volcanic eruptions. One of them was the one that cooked Neanderthals, and another happened 15,000 years ago. The most famous eruption, though, happened in the 16th century, and it was horrifying. The year was 1538. For years, the people of Paswali had noticed something unsettling. Land that once sat below the waves was slowly rising. What was once the sea had become new ground. Rumblings from deep within the earth were terrifying, but had become a normal part of life. Earthquakes started in the early 1530s, small at first, but in just 8 years, they became the norm. Until one day, on September 28th, horrifying tremors shook the ground. By the next evening, as the sun dipped below the horizon, a massive crack ripped open the earth near the ancient Roman town of Supervolcano. From this gash spewed fire, smoke, and a rain of volcanic ash miles away. It was thick and muddy, likely mixed with underground water. The ground trembled as hot pumice rock was thrown high into the air. And then a new mountain began to rise from the land. This was the birth of what we now call Monte Nuovo. Eventually, things seemed to calm down, as if the earth was catching its breath. For days, things seemed quiet. Locals relaxed a bit. They began to approach the new mysterious volcano, a crater with something that resembled boiling within it. People visited it like a new attraction. But then, just days later, the disaster struck again. At night, without warning, a new mountain went wild. A blast from the southern flank hurled scoria, chunks of jagged volcanic rock, into the air. This one was fatal for 24 people. The debris found afterwards was huge and coarse. For centuries after, the only signs of life from the Monte Nuovo were small fumaroles, jets of gas seeping from the earth. But then, even those faded away. Now it's just a lush green cone, a pretty sleeping giant. But the ground near Naples, Italy, is still alive. The Campi Flegrei sits quietly for now, but it might not be for long. It's showing signs it might be waking up again. This supervolcano looks like a hellish landscape, with its boiling mud pits, geysers, and steam vents. Romans and medieval Christians once believed it was a gateway to the underworld, and who can blame them? What's spooky is that recently scientists detected unusual activity under the surface. In 2012, Italian authorities raised the alert level on the volcano from green to yellow, meaning that it needs close monitoring. There are certain changes that usually happen before an eruption. The magma below starts releasing gases, which could weaken the rock above, eventually triggering a disaster. Unfortunately, no one can predict exactly when or if it will erupt. But if it does, the consequences could range from a minor inconvenience for locals to a global catastrophe. Its last tiny eruption happened in the 16th century, and it wasn't too bad. But if history repeats itself, like it was with Neanderthals, we're all cooked. An eruption like that could lead to global cooling, crop failures, and widespread famine. Right now, a group of scientists is trying to get a clearer picture of what's happening beneath the surface. The Campi Flegrei Deep Drilling Project is working to drill a 10,000-foot borehole, hoping to check out the magma chamber up close. But at least for now, the supervolcano remains quiet, and let's hope it stays that way.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the 2 reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long, long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal. But you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean. And you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma, so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hotspots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface, until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Tahoe spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Tahoe volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone Caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Tahoe you already know about, Japan's Caldera, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads up about volcanic eruptions years before they happen. With this new, weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaro, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in a rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the Earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleysite and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say. If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pots, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue, thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory Pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone Supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone Caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other supereruptions in the history of Yellowstone Volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent supereruption was dubbed the Lava Creek eruption. It formed the Yellowstone Caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass.
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943. It started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal Volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.
The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano, as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide. Very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rock strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupo volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupo as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animal's response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius' eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle and not just local eruptions.